Hello everyone, I'm Pratap. I work as a software tools architect at Intel. I'm excited to be here at P4 Workshop and thankful for the opportunity. Today, I'm going to talk about a tool, P4 Designer. We developed it as a proof of concept to demonstrate what it is and how it helps customers. So P4 is a simple but powerful language to program data plane. So why do we need yet another tool, right? P4's popularity has been steadily increasing. We have been extending it to multiple architectures. So when we extend it to different architecture, it's not always going to be a one-to-one mapping between the P4 elements and the hardware blocks. So there's always going to be a gap between writing a vanilla P4 program to writing P4 program for a particular hardware or vendor, right? So programmers usually need to know the intricate details of the hardware architecture and also let compiler know how to map P4 to hardware. So in my experience, most customers either will take long time to get comfortable with this process or come back to the vendor for validating the P4 before deploying it. So P4 Designer uh, is trying to address some of these issues and make life easy for P4 programmer. So here are some of the requirements or the wish list that we collected. Make it easy to navigate the hardware mapping, hide as many hardware details as possible, and also display only the relevant portions while editing in UI. Protect customers from future changes to mapping or the compiler. That way, we can ensure backward compatibility. Apart from that, visual representation of the whole P4 structure and the mapping and showing the mapping on UI is very useful. And it can also auto-generate P4 code from UI. Another important feature is uh, we can validate all the mapping, configuration, and interdependencies very early in the process, even before we send it to the compiler. So P4 Designer has two main flows. One is you start from scratch, build P4 from the UI, and then continue editing offline. Or you can load an existing P4 or set up P4 files and modify them through UI. Right. So here is a very high level architecture for the second flow. Um, we select P4 file from the front end and send it to the backend. Backend picks up all the relevant P4 files and converts them into intermediate notation. So it uses P4 compiler for that. We're using JSON as intermediate notation. This is used to restore P4 structure as well as load UI elements. Right. So we're going to demonstrate this one, but before I hand it over to Sharmila for the demo, I want to mention one thing. For the demo purpose, we replaced our hardware pipeline with a dummy pipeline to avoid disclosing any information which may be under NDA. This is obviously not a replica of any vendor's pipeline, but good enough to demonstrate what the tool does. With that, I'll pass on the baton to Sharmila.
Hi everyone, myself Sharmila, working as a cloud software development engineer at Intel. Now let's get started with the P4 Designer demo. So this is the homepage of the P4 Designer tool, where the user is given provision to either create a new P4 from the scratch, or the user is given option to upload the existing P4 and visualize the properties of the P4, and user is also given option to add or delete any properties and get the updated P4 back. Now let me choose the upload existing P4 option. So before choosing the P4 file, which I'm going to load in the UI, let me show how that particular P4 looks like initially. So this is the P4 which I'm going to load into UI. So it does contain some generic include files and the package configurations, and followed by the P4 annotations, and then the control block, which this control block contains 5 different logical tables, where each logical table contains its respective keys and actions. So now let me show how this thing is getting loaded into the UI. And now I'm going to choose that P4 file, which I have shown. So if once I've clicked on to done, in the right side, we can see that the main parser and the main control block got enabled. So for the proof of concept, which we did for the P4 designer, the functionality of the parser block was not enabled. But if we click onto the main control, then it will navigate us to the table graph page where we can visually see the different logical tables, which I have shown the before already. So we can see the 5 different logical tables and in the UI format. So for example, if we click on to the edit option over here, then we can see the table properties associated with this eForward table. So the table name, table type, size, hardware block to which it is getting mapped to, all these details are getting displayed, and the keys and the actions, action details of this particular eForward table is also displayed. So apart from those things, the hardware mapping details, say MC group index, key compression with respect to eForward table is also displayed, and these options are editable. For example, this MC group index values 8 initially. Now let me change this one to 4, for example, and enable this compression key. So this checkbox is disabled. Now let me enable it. So once I have enabled it, the final P4 should have the value 1 for this key compression. That's the meaning. So now, there are few features which are logical table independent and which are respect to the physical blocks. So let me show some physical properties with respect to the L2 stage. So once I clicked on to the L2 stage, we can see the switch ID, the port ID to switch ID mapping. So these options are also editable, and we can see that getting reflected in the generated or the updated P4. So all these changes or the property changes are in the UI are getting captured in the JSON format. So now if we want to see the JSON format, the UI JSON in this case, then if we click onto the UI JSON tab, then we can see it. So all the generic include files from the P4 is also captured. So along with that, so I have changed the properties, the hardware block information of the eForward table in the UI in the previous page. So I have enabled the compress key, and then I have changed the MC group index to 4. And also I have changed the L2 block properties, say the switch ID and the port ID. So these changes are getting reflected, is also getting reflected in the UI JSON. So now if we click onto the generated P4, then we can see the updated P4 that is getting generated. So I've clicked onto the generate P4 option. Then we can see that the eForward for the eForward table, the compress key enable, that option is 1, which means that I have enabled that option in the previous page. And also I've changed the MC group index to 4. So that change is also getting reflected in the updated P4. So now if I want to show another one property, say creating a new table. So in this case, now let me create one new table. For example, in this case, it's table 6. So if I can see this kind of a table component is created once I click on to create table, and I can change the properties of it by clicking on the edit option. So now let me change the name of this table to forward IPv4 and the table type to, for example, ternary, and change the size of the table to 1024, and we can see that the hardware mapping as well to ACL block. So if so once I have configured the hardware block mapping, then we can see that this mapping from forward IPv4 to ACL, that is this line, got enabled. So this indicates the mapping from the logical to the physical block. So now let me show how the created new table is getting reflected in the UI JSON and as well as in generated P4. Now, if I click onto the UI JSON option, then we can see the new table, say forward IPv4, got created, and it got has the match type as ternary, and I've configured it to ACL block. So all these are getting captured in the JSON format. And if I click onto the generated P4 option, then we can see that the new table, say forward IPv4 skeleton, got created in the P4, and along with that, so I have mapped the forward IPv4 table to the hardware ACL block. So that mapping is also captured in some format, in a form of an annotation. So now let me go back to the table graph page and talk about the validation module. So so there are 2 types of validation possible. So, and this validation module acts as a key term, key point in this P4 designer tool. So if you can see in the hardware mapping, the range check is enabled. That is, the MC group index can have the value between 0 to 15. So if the user wants to change the value, then he's not given any provision to change the value above 15 or below 0. So this kind of range check and the validation is possible in the initial stages itself. And so with this help of this kind of validation, the user may or may not have any in-depth knowledge of the physical hardware or the pipeline in order to create this kind of P4. So any silly mistakes can be avoided with this help of the tool. And also there is another one validation, the hardware, the logical to hardware block mapping validation. So I have chosen the table type as ternary here. And if we can see under the hardware blocks, the only hardware block which we can map to, only hardware block to which we can map this forward IPv4 table is ACL. So all the other blocks are disabled. So this kind of validation is also possible. So for example, if I can change this one to hash, then the hardware block which I can map to is only hash. So this kind of logical to physical table mapping validation is also possible with the help of P4 Designer app. So there are a few things. Say the keys and actions in any table is not editable as of now, but this P4 Designer tool is just crossed the proof of concept stage. So everything like editing keys and actions will be enabled in any future full-fledged implementations. So yeah. So with the help of this kind of a tool, the existing P4 is also maintained, and whatever that we have added or changed, those changes are also getting captured and reflected in the updated P4. Yeah, that's all. Thank you.